Okay, for problem number 5. Problem number 5. Here I've got a new car priced at $15,000. So the value of the new car is 15 grand. Okay? At year 0. Okay? And 10 years later, the value is now $3,000. Okay, 10 years later. All right. So think about this. If we make this into a T table and we say that the value is dependent upon the age or time, and this is in years, and this is in bucks, so we could say at year 0 it's 15,000, and at year 10 it is 3,000. If we use straight line depreciation, actually we're talking about a line there, so we're going to be using a linear equation. That's what we're finding. So let's calculate the rate. So 1, calculate rate. And rate is slope. Rate is slope. So slope is y2 minus y1 over x2 minus x1. So if this is my second point, and this is my first point right here, then this becomes 3,000 minus 15,000 over 10 minus 0, which is negative 12,000 over 10, which is negative 1,200 over 1. So basically I'm losing $1,200 a year. Now my vehicle is depreciating, becoming less in value by $1,200 every year. Okay? So that's my rate of depreciation. So for A, the car depreciates in value by $1,200 per year. Okay? Now I'm jumping around here a little bit. I'm going to go to D because that will help me do B, C, and E easier. Alright, so think about this. On D it says write the equation that relates the value of the car to how old it is. Alright, so if the value, I know that my rate of depreciation is negative 1,200 times the time in years. And at year 0, my car was worth 15,000. So that's my y-intercept. So think of this. This is a linear equation in slope-intercept form. Linear equation in slope-intercept form. Okay? Now I can do B very easily. B asks you what is the value of the car 7 years after it was purchased. So to find the value after 7 years, we simply go V equals negative 1,200 times 7 plus 15,000. So now it's just math. V, negative 1,200 times 7 is negative 8,400 plus 15,000. And if I subtract 8,400 from 15,000, I believe I get 6,600. Value is $6,600. Okay, so that is B. C, okay, C, it asks, how old will the card be when the value is 0? So all I'm going to do is take this equation, V equals negative 1,200 times time plus 15,000, and I'm going to replace the value with 0, and I'm going to solve for t. So I got 0 equals negative 1,200 times t plus 15,000. If I subtract 15,000 from both sides of the equation, now I get negative 15,000 is equal to negative 1,200 times t. The next step would be to divide both sides of the equation by negative 1,200. The right side turns to just t, 1t, and 1 times t is t, so my time, and 15,000, negative 15,000 divided by negative 1,200 is a positive 12.5. So the amount of time is going to be 12.5 years. So that was C. We already did D. And E, we simply had to draw the graph. And this is a pretty easy one to draw. My horizontal axis is going to be time in years. My vertical axis is going to be value in money. Okay? So think of this, it has a negative slope. Like so. This point is going to have, at year 0, it had a value of 15,000. Okay, here at 12.5 years, it had a value of 0. So those are my 2 points.